Hi, I'm just making this video in case you have some difficulty with Edgenuity and you're not able to get in right away. That this is hopefully going to at least be able to watch kind of that first couple of lessons here. So I hope this will help until you're able to get into it. Um, let's keep our fingers crossed that you'll be able to get in soon. So when I open up the lesson viewer, so I know you know how to go through like your to-do list and click on lessons. You can also go into, when you get into this lesson, you can slide this little purple line over here and you're able to view every single lesson you'll have in this entire course and then all the quizzes and things like that. The first lesson, Intro to Matter, the very first link on top, if you click on that, that should open a separate kind of note sheet here. Now you can't type into this, unfortunately. It's kind of a pain. It's not an editable version of a PowerPoint or PDF, but you can print this out or download it and use it as a guide. It would be super nice if everybody were able to print this. If you have a printer, that's probably the best way to go. If not, then have it up on your screen and kind of take notes on these things here. Have fill in the blanks kind of as you're going through the lesson, because that's going to be a great note guide for you to use at the end of your lesson. The one thing that I would say is, since these are your notes, you are able to use your notes on all your quick checks and quizzes. So if you have this completed, or you take notes, alongside of it, then you can use that when you take your quiz at the end of this unit. Now I'm going to go through kind of some of the Edgenuity videos with you. I didn't know for sure what the best way to do this would be, so I'm just going to try to use my screen recorder to record them and see if that helps us to have you follow along. It's not the ideal way, like I said, but it doesn't really have like it would be nice if there was like a transcript or something that comes with this, and I don't see that as a tool. So I'm just going to throw that closed captioning up just in case we have a hard time with the volume. And I'm going to hit play and then just let you listen to this through my speakers. And we'll kind of go slide by slide, and you'll just have to kind of follow along with my video instead of with the video through Edgenuity. Like I said, not ideal, but hopefully it's at least something that'll help for the interim until we get everything kind of fixed here. I just want to make sure the volume's at 100% for this, because she's kind of a quiet speaker. All right, let's go ahead and do this.
Inquiry process that scientists use to ask and then answer questions. That's a process that anyone can use to ask and then answer questions about the natural world. Take a look at this picture here. What objects do you see in this picture? It's a snapshot of sort of everyday life, right? So you see things like bicycles and trees, sidewalks, even people. The question is, what are all of these things made out of? That's a question that scientists have been asking for centuries. And that's the question that we'll be answering next. In this image, you see a family or some friends going kayaking and canoeing, and you see also trees, the lake, the clouds, the paddles. There's all kinds of objects in here. The question is, what are all of these things made out of? The answer is matter. Matter makes up all objects and organisms, or living things. So the lake, the trees, the clouds, even the people, and even the air around them is made out of matter. Now, have you ever wondered, if everything's made out of matter, then what's matter made out of? Well, matter is made up of very small particles called atoms. Let's talk a little bit more about atoms. They are the smallest unit of matter, and their origination, or the idea of atoms, goes all the way back to 5th century BCE with Democritus, a Greek philosopher, who believed that you could break something down until you finally reached a point where it could not be divided anymore. In fact, the word atom means atomos, it's a Greek word, and atomos means it cannot be divided anymore. So if, for example, I had a cookie that I wanted to share with someone, and then I wanted to break that and share it with someone else and continue sharing until I've shared with all my friends, and I broke it down and broke it down until I had even just a small a crumb that I couldn't even see, and I was still trying to break it down, eventually I'd reach a point where I could not break it down anymore. And that's the point at which I've reached an atom. Now, Greek philosophers believed that there were lots of different kinds, several different kinds of atoms, and that the combination of combining those in different ways would then form everything that we see around us. Which they were onto something. That was partly true. They are the building blocks of everything we see around us, and there are different kinds, but there's more than just a few. There's actually over 100 types of atoms, and those combining in different ways is what forms everything around us. Now, atoms are so small that you cannot even see them, with a microscope. In fact, they're so small that here's an interesting fact. If you take one piece of hair from your head, if you were to go the width of that hair, you would pass by over 1 million atoms. Select the statements about matter that are true.
So do your best here to think about what you think might be the correct answer, because it won't let you move on from the screen until we select the correct answer. So living things are made of matter, true, but non-living things are too. Matter is made up of tiny particles called atoms. Atoms were discovered in the 21st century. She just talked about a Greek philosopher, Democritus, so that's not true. Atoms cannot be divided and still retain the properties of its original state. That is true. A single atom can be seen only with a microscope. Well, we know that's not true because she said it was false.
All objects and living things are made up of matter. Matter is made up of tiny particles called atoms. The idea that matter is made up of atoms was first considered by Greek philosophers in the 5th century BCE. Atoms were named by the philosopher Democritus after a Greek word meaning cannot be divided. Previously, you learned that all objects and organisms are made out of matter, and that matter is made out of teeny tiny particles called atoms. Take a look at this image. You see a girl, she's made out of matter, and the box sitting next to her. It's also made out of matter. Now, what if the girl wanted to measure how much matter is contained in the box? Well, how would she go about doing that? Next, that's what we're going to discuss, how matter can be measured. Mass is the amount of matter in an object. Now, different objects and organisms have different amounts of matter, so they therefore have different amounts of mass. In fact, if you take a look at this image, you'll see two dogs. They're both dogs, but they obviously have different amounts of mass or matter. The Great Dane has much more mass than this little tiny Chihuahua. Mass can be measured in kilograms, a standard unit of kilograms, or grams. Grams would be used if you're measuring something small, because remember, there are 1,000 grams in 1 kilogram. So something small like notepad, little sticky notes, or even a pen, you might measure with grams. The dogs, you'd probably measure with kilograms. In fact, the Great Dane would probably be about 55 kilograms, whereas the little Chihuahua probably only about 3 kilograms. Now let's take a look at how you can compare two objects using a tool called a balance. You've probably seen these before. Here is our balance, and it has a pointer in the middle to show which object has more mass, and it has some hands to put objects on. So if you look at this first one here, you can see a bowling ball and a basketball. The bowling ball obviously has a much greater mass than the basketball. Actually, it has about 10 times the amount of mass as the basketball. And you can tell this because the balance has moved all the way down on this pan under the bowling ball, and the pan underneath the basketball is up high. The pointer in the center is also pointing toward the bowling ball. In the next picture, you can see the same balance being used. And here we're comparing two different objects that have completely different shapes. So we have a football and a soccer ball. Now, in this case, it looks like they're about the same amount of mass because the pans are level and the pointer is pointing directly straight up. So the football and the soccer ball have about the same amount of mass. Consider the scenario, then respond to your classmate's statement.
I'm just going to put an X in here, and you can kind of think about this for a moment, okay?
Recall the example of the bowling ball and the basketball, which were approximately the same size. How did their masses compare?
Okay, apparently I have to put no in here. I don't know how they're supposed to be assessing this. Maybe they need you to have a certain number of words. Okay.
Different objects contain different amounts of matter, even if they are the same size. Therefore, two objects of the same size can have different masses. Use the image to compare the mass of the two objects. The mass of the watermelon is greater than 2 kilograms. Weight is the downward pull on an object due to gravity. If you've ever seen someone try to pick up a really heavy bowling ball or even a backpack that's shoved with tons of books in it, you can actually see them sort of being pulled down with weight. So when you say that something's heavy, what you're actually saying is that there's a strong pull of gravity on that object. Here's a spring scale in a grocery store that you may have even used one before. You put the produce on the tray, and the pull of gravity pulls that object down, and then you can measure it up above. This is called a spring scale. Now, scientists use a unit called newtons in order to measure weight. In the United States, we typically use something called pounds, and you're probably a little more familiar with that when you're talking about weight. Now, mass and weight are very easy to confuse, so let's take a little bit closer look at those two different things. Mass and weight are not the same. Mass is the amount of matter that's in an object. Weight, on the other hand, is the downward pull of an object due to gravity. So it's based on the gravitational pull. On Earth, 1 kilogram has a weight of 2.2 pounds, but only when it's on the Earth. If it were on the moon, then it has a 1 kilogram has a weight of 0.36 pounds. That's only a sixth of what it is on the Earth. So a person that weighs 120 pounds on Earth, on the moon, we divide it by 6, and you've probably already figured out, on the moon this person would only weigh 20 pounds. So the weight changes due to the gravitational pull. A person on Earth does not weigh the same as they would if they were to fly to the moon. But their mass remains the same. They don't lose any matter or any mass in their body if they move from the Earth to the moon. That amount stays exactly the same. Drag and drop the titles to match the definitions with the correct terms. Mass is the amount of matter in an object. It is measured using a balance. Weight is the down pull on an object due to gravity. It is measured with a scale. Previously, you learned two ways to measure matter, in weight and in mass. Here you see an orange and an apple, and they appear to take up about the same amount of room. So you could say they have about the same amount of volume. Next, we'll talk about volume and learn different ways to calculate the volume of different objects. Volume is the amount of space that an object takes up, whether it's a ball, a box, or even a starfish. Just like different objects have different masses and weights, different objects also have different volumes. And the method that we use to find that volume depends on what the object is and how it's shaped. For regular solids, like a rectangular prism or box, we can use a formula that is volume equals length times width times height. In this formula, the V stands for volume, the L stands for length, which is found over here, W is width, found over here, and H stands for height, which is right here. The units that we'll be using to measure this is in centimeters. Now, it's important to notice that we have centimeters. We need to have the same unit for each dimension in order to multiply them together. Since we're multiplying centimeters times centimeters times centimeters, our answer will be in centimeters cubed. So volume will always be in centimeters cubed, or if we're measuring something larger, it might be in meters, in which case the answer would be in meters cubed. Sometimes you will see, instead of volume equals length times width times height, you'll see volume equals base times height, in which case B stands for base, and the base can be found in a rectangular prism by multiplying length times width. So in this case, we would have length here times the width, and when we multiply that, we will get the base. Let's work through an example together. Suppose you wanted to send a package and you needed to know the volume. Let's say you measured all of the dimensions and you found that the volume of your box, that the dimensions of your box had a length of 9 centimeters over here, a width of 6 centimeters, found right here, and a height of 3 centimeters. How would we find the volume? Do you remember the formula? Volume equals length times width times height. If we already know the values of the length, width, and height, we can simply plug in these values into our formula and solve. So the volume will equal length, which was 9 centimeters, times the width, which was 6 centimeters, times the height, 3 centimeters. When you multiply those together, we end up with a volume of 162 centimeters. And remember, it's going to be centimeters cubed because we've multiplied it 3 different values together. So we have 162 centimeters cubed. Next, you can try an example on your own. Find the volume of the box.
5 times 5 is 25, times 10 is 250.
The volume of the box is equal to 5 centimeters times 5 centimeters times 10 centimeters, or 250 centimeters cubed. There are other regular solids, like rectangular prisms. There are spheres, like balls, basketball, softball. There are cylinders, like cans, which we'll be talking about next, and cones. Now, each of these shapes has its own formula to find the volume. Let's start with the cylinder. A cylinder formula to find volume is volume equals B, which is base, times the height. Now, we've already talked a little bit about base, but we talked about a base in a rectangular prism where the base was a rectangle. Now, in a cylinder, we're talking about a circle. So we'll want to find the area for this circle. On the diagram here, you can see the base is circular. And in order to find the base for a circle, we need to multiply pi, right here, the symbol, which has a numeric value of 3.14, which you won't actually have to plug into your calculator because there's a button on your calculator for pi. Multiply pi times the radius. Remember, radius is from the center of the circle to the outer edge. And we'll need to square that. So it's actually pi times the radius squared. So in order to find volume for a cylinder, volume is base, which is pi 3.14 times radius squared, then times height. And our height is found right over here from top to bottom. So cylinders have a pretty simple formula. Volume equals base times height. Now, cones are really close to this. They're a little bit different. Again, they have their own formula. Here's a picture of a cone. I'm sure you're familiar with cones, ice cream cones, traffic cones. It actually is the shape that was exactly on my son's head this weekend at a birthday party. It looks like a party hat. So a cone has a volume formula that is 1/3 times base times height. Do you see the similarities between the cone and the cylinder? The cylinder formula was simply volume equals base times height. The only thing that we've changed is that it's now multiplied by 1/3, which means that it's actually divided by 3. So if we were to write this out, volume is equal to base times height divided by 3. And if you'll recall, the base is pi times radius squared times the height, and again divided by 3. Now it's important to notice a little bit of difference between the cylinder and the cone. In the cylinder, we were measuring the side of the cylinder for the height. In a cone, we'll want to measure from the center point of the circle to the very tip of the cone. And you can see that distance is a little bit different than if we were to measure on the side here. So we don't want to do that. We just want to go with the center of the circle to the tip in order to find height for a cone. So let's take a look at this example together and we'll work through it. What is the volume of a cone with a height of 20 centimeters? So let's add that in, 20 centimeters, and a radius of 6 centimeters, and round your answer to the nearest tenth. So let's just plug in our numeric values into the formula. Volume equals base, which is pi, times the radius, that is 6. Remember, we're going to square it, squared, times the height, which is 20, and then all of that divided by 3. And you can use a 4-function calculator to perform this calculation. And what you'll end up with is, if you've already done it, 753.98. And if you'll recall in the example, it asks us to round to the nearest tenth. Since we have 0.98, that will round to 754. And it's really important to remember to get your measurements in there, your units. Remember, we are doing this one in centimeters. All of our measurements were in centimeters, so we have 754 centimeters cubed. Next, you're going to try one on your own, and don't forget those measurements, those units of measure. Find the volume of the cone. The volume of a cone with a height of 27 centimeters and a radius of 13 centimeters is 4,778.4 centimeters cubed. Here you see a picture of a sphere, like a basketball or a globe. This is the last of the regular solid objects that we'll be finding the volume for. The sphere volume is found with this formula. Volume equals 4 divided by 3 times pi times radius cubed this time. So here's our radius from the center out. And remember, we're going to want to cube this. So put a little 3 to remember. Now this is really simple. Let's look at the example. What is the volume of a sphere with a radius of 9 centimeters? There's only one number, one numeric value to plug into this, and then round our answer to the nearest tenth. So if our radius is 9, let's go ahead and plug that into this formula. So volume equals 4 divided by 3 times pi times the radius, which is 9, and cubed. And if you plug that into your calculator, you will get 3,053.6, of course, centimeters cubed. Review the formulas for calculating volume. The volume of a rectangular prism is calculated by length times width times height. A cylinder's volume is calculated by pi times radius squared times height. A sphere's volume is calculated by 4/3 times pi times radius cubed. And a cone's volume is calculated by 1/3 times pi times radius squared times height. Previously, you learned how to find the volume for different regular solids, like this sphere pictured here in this game of jacks. Now, if you've ever played jacks, you know that jacks are actually pretty oddly shaped. It would be really hard to measure a jack with a ruler in order to find its volume. So how do you think you would find the volume for an oddly shaped solid? Well, that's what we're going to learn next, how to calculate the volume for an irregular solid. Some objects are irregularly shaped, and in order to find the volume, there are no formulas that we can use. So no formula for an irregular solid. Instead, the way that we calculate it is to use displacement, which is just moving something from its original position. In this case, we'll use water, and the water that the object displaces will tell us how much volume there is to that object. So let's take a look at our little jack. In order to use water displacement, we're going to use graduated cylinders, and we're going to start with an initial amount of volume. So here is volume of water only, and you can see on the graduated cylinder that the initial amount is 30 milliliters. Then, very gently, so you don't splash the water and then change the amount that's in there, very gently you would place the object into the graduated cylinder, in this case the jack, and you can see that it's sunk down to the bottom here. And now the water has been displaced or moved from its original position. Now its water line is here, and you can see here between the 30 and 40 we're counting by increments of 2. So this is actually at 35 milliliters. So our initial amount was 30, and our final volume of water was 35. So to find out what the volume of the jack was, it's really simple. We just take the final volume, 35 milliliters, and subtract the initial volume of water, which was 30 milliliters. And I'm sure you can do this in your head. We have 5 milliliters. Now, if you remember, 1 milliliter is equal to centimeters cubed. So you could say that the final volume of the jack over here is 5 centimeters cubed. Determine the volume of a rock. The volume of the rock is 12 centimeters cubed.
Now, for some reason, all of your Edgenuity lessons end in that crazy, weird error message. So don't worry about that because that's just how they all end. So that is the end of your matter instruction. And at this point, you have like a summary. It goes through a little bit here. Let's see. It's really not much. It's just going to summarize what we just did. I feel like it's kind of something you don't necessarily need to go through at this time as long as you took good notes the first time through. And then we have the assignment here.
In this lesson, you learned to describe and measure matter. In this assignment, you will practice what you learned. Complete the statement that describes matter.
So you have to complete the statement. Just kind of a review of that previous lesson, right? Notice I'm not clicking these, by the way. For some reason, if you click these, it kicks you out of this. It's kind of a glitch in the system, so I'm only using the little boxes to navigate.
Select all of the statements that accurately describe atoms.
Really should say atoms cannot be divided and still retain the properties of the atom because we know we can actually split atoms, but it's a little bit technical.
Differentiate mass and weight.
Again, in this case, this is again a question that they asked you earlier. You know that mass is the measure of matter in a substance and weight is essentially the pull of gravity. So I guess I'll have to type that in there because it got mad at me before when I didn't type enough. Okay, so then it's going to ask you what you included. Amount of matter. I didn't include this, but maybe I should have. Mass of two objects are compared using a balance. Yes, weight is the downward pull due to gravity and is measured in newtons and pounds. All of those are true. So it's basically saying to me, Miss Peachy, you didn't quite include enough stuff in your response.
Calculate the volume of the rectangular prism.
So we have length times width times height here, which you have basically 54 times 5, which is 270 cubic centimeters.
Calculate the length of the rectangular prism.
So in this case, they're kind of giving it to you backwards. You're going to take that 104 and divide it by 26. So 13 times 2 is 26, which gives me 4.
Calculate the volume of the cylinder.
Remember that
Notice that there are two calculator tools available. The graphing calculator has the pi key.
Okay, well, I'm not using the graphing tool. I don't even see where you would do that. So just use your own calculator. It's easier anyways. So we have, in this case, it's pi r squared times the height. So radius is 4, so pi r squared. Let's do 4 squared first, which is 16, times pi times 13, which gives us 653.5. No, she wants 100. 653.45. Tricky. They said 100 this time. Okay.
Calculate the volume of the cone.
This is pi r squared, or times the height divided by 3. So same thing we did before. So 3 squared is 9. 9 times pi times height divided by 3. Remember, you're hitting the equal sign in between all of these, by the way. I always do.
Remember that the volume of a cone is equal to 1/3 base times height.
I know. What did I do here wrong? So the radius is 3. 3 squared times pi times 4.5 equals divided by 3. Just like at 42.4. Oh, nearest hundredth. See, it gets mad at me for not putting the right number of decimal places in. Let's try it again. So the prompt isn't always the best way of telling you what you did wrong. In that situation, the prompt may have been better to say, hey, remember to round to the nearest hundredth place. Okay.
Calculate the volume of the sphere.
So 4/3 pi r squared. Radius is 8. We'll square it times pi equals times 4 equals divided by 3 equals 268.1.
Remember that the volume of a sphere equals 4/3 times pi times radius cubed.
Oh, radius cubed. I did that part wrong, guys. Okay. So 8 cubed times pi times 4. Remember, I'm hitting equals after each one of those steps. Divided by 3 equals 2,144.7.
Calculate the volume of the key.
Starts off with a volume of 10, 12, 14, 16, 17. And it ends up with a volume of 22, 4, 25. So 25 minus 17 is 8. Again, see what it does at the end? It always does that, but you're still finished with that part of the lesson. Okay, that being done, you can go ahead and complete the quiz. I don't think you need Edgenuity to do that, so you can go ahead on the next screen and just complete your quiz here, okay? So that's one lesson down, and hopefully that gets you through lesson 1. And I'll go ahead and record the other lessons as much as I can and get those to you as well, and hopefully that at least gets you to the point where you can get into Edgenuity.